Okay, so let's just practice going from interval notation to that, because that's kind of the biggest one, all right? So I think discrete cases are rather easy, but the interval notation, let's focus a little bit more on that. So first, let's just look at the x-axis, all right? We'll concentrate on that. Again, because of the shading, I'm indicating to you that we do have an interval. I'm talking about all the numbers between -4 and 5. However, what I'm now using are open circles. So these open circles mean that these boundaries are not part of the set. They're forming the set, if you would. We're talking about a left bound of 4 and a right bound of 5, but because we're not including them, we are now going to use parentheses. And so that's comparable in the last one right here, because we had the endpoints were included with closed circles. We use brackets to represent the boundary. So the sets are very similar. We're talking about everybody between -4 and 5, but this set actually included the endpoints, and this set actually excludes the endpoints. So we can only be like 4.9, 4.99, 4.9999, whereas here we can get close to 5 as we want, including 5. So very, very similar sets, but unique in that feature. So let's stay along the x-axis. So this x-axis, if we look at, again, my shading indicates that we're talking about all the numbers over to the right of -1. So what bounds me to the left is -1, and what bounds me to the right is, well, we're not bounded. We're going to go constantly to positive infinity. Positive infinity is on that side, negative infinity is over here. And so -1 is included in the set because of the closed circle, and then infinity, we can never actually equal infinity. So whether it's positive or negative infinity, you will always have an open parentheses, because you can never equal infinity. And that's what these brackets mean, that you are actually equal to the endpoint. And if you guys ever figure out a way to be equal to infinity, let me know. We're going to make a lot of money. All right. Otherwise, we're just going to use open parentheses. In the next set, again, we're pretending we're along the x-axis here. The shading indicates that we're talking about all the numbers, right? The interval over to the left of 2. So what bounds me to the left? Well, we remain unbounded. So that's negative infinity. What bounds me to the right? Well, we're bounded by this value of 2. And then both are going to be open. 2 is open because we're an open circle, and negative infinity is open because we can never reach it. We can never actually be equal to it. So there's your interval notation for that picture. The last picture that I have here, again, I'm indicating that I'm talking about everybody between -3, and that looks like 3. So my left bound is -3, my right bound is +3. There's a closed circle here, so that means we're going to use a bracket at -3, and then I'm an open circle here, so we're going to use a parentheses at 3. And so that's a very unique set, because we're talking about everybody between these two values, but one we're equal to, the other we're not. Okay, so hopefully that gets you used to the idea. Let's go look along the y-axis, right? And it's going to be the same story. It's just up and down rather than left and right. So again, I'm indicating that I'm talking about all the numbers between -3 and 3. So what bounds me below is -3. What bounds me above is +3. Open, open, so parentheses, parentheses. We don't include that. So that's what that would look like along the y-axis. The next set, the indicating shading means we're basically all the numbers above -5. So what bounds me down below is -5. What bounds me up above is, well, we're going to positive infinity. So we're open here, and we are closed there because of the closed circle. So that would be the interval for that guy. Okay. The next example, we have an open circle at 3, and the shading indicates that we're below 3, going all the way down to negative infinity. So where am I below? What am I bounded by below? Negative infinity. What am I bounded by above? +3. And in both cases, we'd be open because 3 is open because of the open circle, and then we can never actually equal negative infinity. So there would be our interval notation. We're talking about everybody from negative infinity to 3. Last but not least, we have a interval again indicated by the shading. We're bounded below by -2 and we're not including it. And we're bounded above by 4 and we are including it. So when I take a look at this graph, what I basically have is we're bounded below by -2 and we're bounded above by 4. We can't be equal to -2 and we can be equal to +4. And so there would be our interval notation for that. So let's put it together, right? So rather than looking at them separately, what does it look like for what we're going to be doing with regard to a function? Again, notice that all 3 graphs are functional. They all pass the vertical line test, meaning 1x creates 1y. So we have a function. And when I look at this, when I'm looking for the domain, I'm basically asking what values of x are creating outputs. And so if we kind of look at what's covered, all right, so imagine it looks like we're starting at -2, and then all the x values are essentially covered all the way up to, it looks like +4 right there. So again, if we were to kind of maybe collapse this graph, it would basically shade or cover that part of the x-axis. There's no graph associated over here. There's no graph associated over here. So these values are uncovered. And so when I look at the little interval along the x-axis, it looks like we start at -2 to the left, and we have +4 to the right. We are closed at -2, and we are open at +4. So there would be the domain for this particular function. What about the range? Well, now we're looking at what's covered along the y-axis. So the lowest point seems to be about -1. And all y values are being created all the way up to, looks like 1, 2, 3, looks like also 4. And we're open. All right, so open and we're closed. So what bounds us below is -1. What bounds us above is 4. -1 is closed because of the dot, and +4 is open because of the open circle. So we're basically asking again what's covered. These y values up here are not in the range because there's no graph associated with them. They're uncovered. These y values down here are not in the domain because they're not covered. And again, back to the definition, the domain consists of x values that create y values. And so from -2 to 4, we're creating y values because I see the graph associated with those. What's the range? All the outputs from that input. So we can see by the graph that all these y values from -1 to 4 are associated with the graph. They're covered by it. Okay. Next graph. These arrows are important here because they indicate that this is going to go up forever. And so what's my domain? Well, since these arrows are indicating that this goes on forever, eventually we're going to cover all the x-axis all the way to -infinity. And we're going to be eventually covering the positive axis all the way to +infinity. So this guy has a very strong domain. That basically means that we're defined for all real numbers, -infinity to infinity. Strong functions when you can put anything you want in there and get something out. So very, very strong. What about my range? Well, when we look what's covered along the y-axis, right, its lowest y value looks like it's at 3. And then it's covered all the way up to +infinity. So we're bounded below by 3. We're bounded above by infinity. There's a closed dot there, so I have a closed bracket, and then infinity is always open. So that would be the range for that function. So what's covered along the y-axis and what's covered along the x-axis. Well, the x-axis is covered throughout, and the y-axis basically starts at 3 and above. Last one, for this function here, looking at the domain, it looks like we're starting at -3. Right, and then basically the graph is covered, right? The x-axis is covered because of that arrow. We're going to go on forever in that direction. So that's +infinity. Open, open, open because of the circle, and then open because we're unbounded. That we're going to go on forever there. What about my range? Well, what's covered on it? If you look at that dot, it looks like it's starting at about 2. And then the graph is basically covering this part of my y-axis. So we're going to bounded below by 2, bounded above by infinity. We are open, so that's open, and infinity is always open. So that would be your domain and range for that picture of that line that we have. And again, I like to use the idea of what does the graph seem to cover? What part of the x-axis is the graph covering? Right? What part of the y-axis is the graph covering? And that's how you can basically bring it back to this and talk about your domain and range along the x-axis or along the y-axis. All right, so hopefully that's another good introduction. We're going to practice a little bit more with several examples.